डॉक्टर बाबासाहेब आंबेडकर ओपन यूनिवर्सिटी.
Hello dear students, I Assistant Professor Nilesh Bukhani welcome you from Chaitanya Studio, Dr. Babasaheb Ambedkar Open University, Ahmedabad. Our today's agenda is OSI reference model, then history of the OSI model. Then we will see advantages and various disadvantages of OSI reference model. Then we will see one example to understand OSI reference model, and last one is TCP/IP protocol suite. So first of all, let's understand what OSI reference model is. So OSI means Open Systems Interconnection, is a reference model for how applications communicate over a network. Then this model focuses on providing a visual design of how each communications layer is built on top of the other, starting with the physical cabling all the way to the application that is trying to communicate with other devices on a network. A reference model is a conceptual framework for understanding relationships actually. So the purpose of the OSI reference model is to guide technology vendors and developers so the digital communications products and software programs they create can interoperate, and to promote a clear framework that describes the functions of a networking and telecommunications systems that they are using. So most vendors involved in telecommunications try to describe their products and services in relation to the OSI model. This helps them differentiate among the various transport protocols, then we can say addressing schemes and communication packaging methods. So although it's useful for guiding discussion and evaluation, the OSI model is theoretical in nature. Yes, it is theoretical in nature and should be used only as a general guide. That's because few network products or standard tools keep related functions together in well-defined layers, as is the case in the OSI model. So the transmission control protocol means TCP/IP, transmission control protocol suite, is the most widely used network protocol. But even it doesn't map cleanly to the OSI model. Now, after understanding OSI model, let's have a brief history of the OSI model. So in the 1970s, technology researchers began examining how computer systems could best communicate with each other. So over the next few years, several competing models were created and published also to the community. However, it was not until 1984 when the International Organization for Standardization, means ISO, took the best parts of the competing networking reference models to propose OSI as a way to finally create a framework that technology companies around the world could use as the basis of their networking technologies. So ISO has given that particular importance to OSI. So from ISO's perspective, the easiest way to create a conceptual model way to organize the models into different abstraction layers required to organize and send data between computing systems. So looking inside each abstracted layer to see the details shows one part of this network communication process. Each layer can be thought of as a separate communication module or piece of the puzzle. But To actually accomplish the goal of sending data from one device to another, each module must work together. Now, let's understand how the OSI model works. So, information technology networking professionals use OSI to model or conceptualize how data is sent or received over a network. Now, understanding this is a foundational part of most IT networking certifications, including Cisco Certified Network Associate, means CCNA. So this model is designed to break down data transmission standards, then we can say processes and protocols over a series of 7 layers, each of which is responsible for performing specific tasks concerning related to sending and receiving data. Now the main concept of OSI is that the process of communication between two endpoints in a network can be divided into 7 distinct groups of related functions, or we can say layers. Each communicating user or program is on a device that can provide those 7 layers of functions. In this architecture, each layer serves the layer above it and in turn is served by the layer below it. So, in a given message between users, there will be a flow of data down through the layers in the source computer across the network, and then up through the layers in the receiving computer also. Only the application layer at the top of the stack doesn't provide services to a higher level layer. So the 7 layers of function are provided by a combination of applications, then operating systems, network card, device drivers, networking hardware and protocols that enabled a system to transmit a signal over a network through various physical mediums. That includes twisted pair wire, then copper wire, then fiber optic, Wi-Fi or long-term evolution means LTE with 5G. Now we are jumping on our next topic. So let's discuss advantages of OSI reference model. So there are many advantages of the OSI reference model. Some of those are we are going to discuss over here, like model is a truly generic model. The OSI model works as a standard model in data communication. Then OSI model is helpful if you want to buy the required software or hardware to build your own network. Then layers in the OSI model architectures can be distinguished, and every layer has its own importance according to their interfaces and services and protocols. Then the OSI divides all the processes of data communication into simpler and smaller. The protocols are hidden in the one model, so protocols can be implemented in the OSI model. So OSI model is a standard model, so it can adapt all features of other protocols. So the OSI model can facilitate, then we can say component like component development, then we can say concept of modularity, then design of the network, then troubleshooting of the network. Then the OSI model increases the learnability of the network. So it supports both connection oriented and services, and we can say connection less and connection oriented services. Now let's discuss some of the disadvantages of the OSI model. Actually, there are many disadvantages to the OSI reference model. Some of those we are going to discuss over here. The OSI model is a theoretical model. Sometimes it can be a difficulty if the appropriate technology is not available. the OSI restricts its practical implementation. Then the OSI model is a very complex model. So the initial implementation of the OSI model is slow. The initial then implementation of the OSI model is also costly. So there is interdependence among the OSI layers also. So OSI layers cannot work in parallel. Each upcoming layer needs to wait to receive the data from its predecessor layer. So for an example, the application layer receives the data from the presentation layer, and the presentation layer needs to wait to receive the data from the session layer, and so on. Some layers like the presentation layer and the session layer have very little functionality when practically deployed. So the duplication of services in various layers is a problem in the OSI model. So some services are offered by multiple layers. Some of these services let's discuss some of the services. We can say flow control, then error control and addressing, etc. So the OSI model is a theoretical model and does not offer appropriate solutions for the practical implementation of the network. Now, the OSI model did not fulfill the practical needs also. So the OSI model was labeled as inferior quality. Now we will discuss an example of OSI reference model. Actually, a web browser serves as a good practical illustration of the OSI model and TCP/IP protocol suite. The web browser serves as the user interface for accessing the website. Now the browser itself does not function at the application layer. Instead, the web browser invokes the hypertext transfer protocol, means HTTP, to interface with the remote web server, which is why HTTP means hypertext transfer protocol precedes every web address. Now the internet can provide data in a wide variety of formats. So a function of the presentation layer means common formats on the internet like HTML means hypertext markup language. Then we have XML, extensible markup language. We have also PHP, hypertext preprocessor. Then we have GIF, graphics interchange formats. And also we have JPEG, means Joint Photographic Experts Group. So any encryption or compression mechanisms used on a website are also considered a presentation layer function. Now the session layer is responsible, for establishing, maintaining and terminating the session between devices and determining whether the communication is half duplex or full duplex. However, the TCP/IP stack generally does not include session layer protocols and is reliable on lower layer protocols to perform these functions. Now, HTTP Hypertext Transfer Protocol utilizes the TCP Transport Layer Protocol to ensure the reliable delivery of data. So, delivery will be reliable. TCP establishes and maintains a connection from the client to the web server and packages the higher layer data into segments. So a sequence number is assigned to each segment so that data can be reassembled upon arrival. Now the best path to route the data between the client and the web server is determined by IP, means IP address. Then a network layer protocol also. So IP is also responsible for the assigned logical addresses on the client and the server and encapsulating segments into packets. Now data cannot be sent directly to a logical address. Actually, as packets, travel from we can say as packet travel from network to network, the IP addresses are translated to hardware addresses, so which are a function of the data link layer. So the packets are encapsulated into frames to be placed on the physical medium. So the data is we can say finally transferred onto the network medium at the physical layer. So in the form of raw bits, then we can say signaling and encoding mechanisms are defined at this layer. So as is the hardware that forms the physical connection between the client and the web server. Now we will jump on our next topic, which is TCP/IP protocol suite. So the protocol stack used on the internet is the Internet Protocol Suite. It is usually called TCP/IP after two of its most prominent protocols. There are other protocols as well. Like the TCP/IP model is based on a we can say four layers. Then from bottom to top, these are like a physical layer. From then data link layer comes, then network layer will be there, and at last transport and application layers will be there. So not all layers are completely defined by the model, so these layers are filled in by external standards and protocols. The layers have names but no numbers, and although sometimes people speak of layer 2 or layer 3, so these are not TCP/IP terms. Terms like these are actually from the OSI reference model. So the TCP/IP stack is open, which means that there are no secrets as to how it works. Now, two compatible end system applications can communicate regardless of their underlying architectures, although the connections between layers are not defined. The TCP/IP stack is comprised of modules. Each module provides a specific function, but the modules are fairly independent. The TCP/IP layers contain relatively independent protocols. Actually, those protocols can be used depending on the needs of the system to provide whatever function is desired. In TCP/IP, each higher layer protocol is supported by lower layer protocols. Now we will jump on our next topic. So let's continue with TCP/IP characteristics, like support for a flexible TCP/IP architecture. Then adding more systems to a network is easy. In TCP/IP, the network remains intact until the source and destination machines were functioning properly. Now, TCP is a connection oriented protocol, as we all know. Then TCP offers reliability and ensures that data which arrives out of sequence should put back into order. So TCP allows you to implement flow control, so sender never overpowers a receiver with data. TCP/IP model consists of 5 layers: the application layer, transport layer, network layer, data link layer, and physical layer. So the first actually application, transport, internet, and network layers will be there. So these first 4 layers provide physical standards, network interface, internetworking, and transport functions that correspond to the first 4 layers of the OSI model. And these 4 layers are represented in TCP/IP model by a single layer called the application layer. TCP/IP is a hierarchical protocol made up of interactive modules, and each of them provides specific functionality. In other words, The TCP/IP protocol stack models a series of protocol layers for networks and systems that allows communications between any types of devices. Now the model consists of actually four separate but related layers. You can see in the figure. Now the internet protocol suite is based on these four layers. The TCP/IP says most about the network and transport layer and a lot about the application layer. TCP/IP also defines how to interface the network layer with the data link and physical layers, but is not directly concerned with those two layers themselves. Now the internet protocol suite assumes that a layer is there and available. So TCP/IP does not define the layers themselves. The stack consists of protocols, not implementations. So describing a layer or protocol says almost nothing about how these things should actually be built. So not all systems on a network need to implement all four layers of TCP/IP. Now devices using the TCP/IP protocol stack fall into two general categories: a host or end system and an intermediate system. Now the intermediate nodes usually only involve the first three layers of TCP/IP, although many of them still have all four layers for other reasons. So in TCP/IP, as with most layered protocol, the most fundamental elements of the process of sending and receiving data are collected into the groups that become the layers. Each layer's major functions are distinct from all the other layers. So each and every layer will be different according to their functions. But layers can be combined for performance reasons. Each implemented layer has an interface with the layers above and below it, except for the application layer and physical layers. And provides its defined service to the layer above and obtains services from the layer below. So in other words, there is a service interface between each layer, but these are not standardized and vary widely by operating system. Now TCP/IP is designed to be comprehensive and flexible. So it can be extended to meet new requirements, we can say. Individual layers can be combined for implementation purposes as long as the service interfaces to the layers remain intact. So layers can even be split when necessary and new service interfaces defined. Services are provided to the layer above after the higher layer provides the lower layer with the command, then data and necessary parameters for the lower layer to carry out the task. Now layers on the same system provide and obtain services to and from adjacent layers. However, a peer-to-peer protocol process allows the same layers on different systems to communicate. Now the term peer means that every implementation of some layer is essentially equal to all others. So there is no master systems at the protocol layer. Now communication between peer layers on different systems use the defined protocols appropriate to the given layer. So in other words, services refer to communications between layers within the same process and protocols refer to communications between processes. Now we will understand each and every layer of TCP/IP with their function. So we start with our first layer, which is application layer. So so we are going to discuss application layer. Application layer interacts with an application program, which is the highest level of OSI model. Now application layer is the OSI layer which is closest to the end user. So it means the OSI application layer allows users to interact with other software application. Now application layer interacts with software applications to implement a communicating component. So the interpretation of data by application program is always outside the scope of the OSI model. Now example of the application layer is an application such as file transfer, then we can say email, remote login, etc. So there are various functions of application layers. Like application layer helps you to identify communication partners, then determining resource availability and synchronizing communication. Actually it allows users to log on to a remote host. Then this layer provides various email services also. Then this application offers distributed data resources and access for global information about various objects and services also. Then next one is transport layer. So transport layer builds on the network layer in order to provide data transport from a process on a source system machine to a process on a destination system. So it is hosted using single or multiple networks and also maintains the quality of service functions. So it determines how much data should be sent, where and what rate. Now this layer builds on the messages which are received from the application layer. So it helps ensure that data units are delivered error free, and it will be in the sequence also. Then transport layer helps you to control the reliability of a link through flow control, then error control and segmentation, or we can say desegmentation also. Now the transport layer also offers an acknowledgement of the successful data transmission and sends the next data in case no error occurs. Now TCP is the best known example of the transport layer. Now the important function of transport layers are like it divides the message received from the session layer into segments and numbers them to make a sequence. Now the transport layer makes sure that the message is delivered to the correct process on the destination machine. It also makes sure that the entire message arrives without any error, else it should be retransmitted. So now let's discuss internet layer. So an internet layer is a second layer of TCP/IP layer of the TCP/IP model. It's also known as a network layer. The main work of this layer is to send the packets from any network and any computer. Still, they reach the destination irrespective of the route they take. Now the internet layer offers the functional internet layer offers the functional and procedural method for transmitting variable length data sequences from one node to the another with the help of various networks. Now message delivery at the network layer does not give any guaranteed to be reliable network layer protocol. Then layer management protocols. Then there will be layer management protocols that belong to the network layer are routing protocols, then multicast group management and network layer address assignment. And at last one is we have our network interface layer. So network interface layer of the four layer of TCP/IP model means we can say this layer is also called network access layer. So it helps you to define details of how data should be sent using the network. Then it also includes how bits should optically be signaled by hardware devices which directly interface with a network medium like coaxial, optical, coaxial fiber or twisted pair cables. Then a network layer is a combination of the data line and defined in the article of OSI reference model. So actually this layer defines how the data should be sent physically from the network. This layer is responsible for the transmission of the data between two devices on the same network. Now let's see differences between TCP/IP and OSI. This is our last point to which we are going to discuss today. So TCP refers to transmission control protocol, while OSI refers to open systems interconnection. Now TCP/IP has 4 layers, while OSI has 7 layers. TCP/IP is more reliable, while OSI is less reliable. Then TCP/IP does not have very strict boundaries, while OSI has strict boundaries. Then TCP/IP follows a horizontal approach, while OSI follows a vertical approach. Then TCP/IP uses both session and presentation layer in the application layer itself, while OSI uses different session and presentation layers. Now TCP/IP developed the protocols then model, while OSI developed the model then protocol. So transport layer in TCP/IP does not provide assurance of delivery of packets, while in OSI model this transport layer provides assurance delivery of packets. Then TCP/IP model network layer only provides connection-less services, while connection-less and connection-oriented both services are provided by network layer in the OSI model. So protocols cannot be replaced easily in TCP/IP model, while in OSI model protocols are better covered and easy to replace with the change in the technology. Thank you, my dear students. I hope you enjoyed today's session.